two case studies on privilege escalation, so it's kind of a bit of a demo, but really I'm just demoing the exercise, so it'll save you a little bit of trouble. But it's something that you can refer to when we get into the lab. SQL injection is going to be a bit more theoretical. So there is that will come later sometime when you're going to play around with it a little bit, but that's going to be next class. So I'm just kind of introducing the concept. Okay. Any questions before I get started on the quiz? Not the quiz, the lecture. Don't freak out. It's not a quiz. Okay, let's do this thing. Okay, so the concept of privilege escalation is just you get access to an account or something like that, but you have limited access, and then you want to gain more. And so, getting a foothold into the network, you may do that through a web server. The web server doesn't have a lot of permissions, a lot of access. So then you start looking around for ways to escalate your privilege, right? Um, So there are lots and lots of different ways to try and do this, and it changes with time, right? So I'm just going to look at a couple of examples that have been used historically in real world situations, just so you can get an idea of some of the sneakiness that's involved in some of this stuff. And both of these are Windows oriented issues. Okay, so Windows operating systems were impacted. Um, one of them was more architecture wide. It wasn't just Windows OS. And one of them was just Windows OS. Okay. But both of them involved real unpublished 0 days. So when they were discovered, there was no patch for it at the time. Okay. So one of them was actively exploited in the wild, while the other existed for years, but we don't know, no one knows it to have been leveraged in any way. So this was more of a research discovery. It's a neat hack, but they don't believe it was ever used out in the wild. Okay, so they found it, they patched it, and that's it. We're covered now. Okay, so what I have is a virtual machine, which is, let me just go there. And that's available for you too. It's up on SharePoint under the hacking folder if you get the base 7 VM. And you extract it, you can play around with this one, okay? So it's a Windows 7 machine at the appropriate patch level. I'll just log off here and show you what you can do with it. So there's the administrative account and there's the tech account. The tech has no admin rights, okay? It's just a regular user. The administrator is the administrator. Um, so the idea with the what we're going to do here is we're going to log in as tech, and we're going to try and gain administrative rights. Okay, now, just for the purposes of ease of use, there's no password on either of these. Okay, so I can log into admin right now. This is just a proof of concept. But I can also log into tech. And the way that we're going to gain access for tech is not going to leverage the fact that administrator has no password. Okay, we're going to use a completely different method. This is just for ease of login and log out. Okay. Okay, so case study one. This is the Windows Task Scheduler hack. I say the Windows Task Scheduler hack, but really there's been more than one in the past. There was one for Windows 10. This one was for Windows 7. I like it because I have a nice little script for it, and it's relatively easy to understand. A lot of hacking techniques really go into the weeds quite a bit, but this one is pretty clear. You can kind of understand without too much difficulty what they're doing, um, and it makes it good for a case study and a bit of practice. You know, so This affected older versions of Windows, so Windows Vista, Windows 7, all the way up to Windows Server 2012, but not 2012 R2 or whatever it was called. Service Pack something, R2, I think it was. So anything up until these, they were all vulnerable at the time. This was a real zero-day exploit, and it did exist for quite a long time without being noticed. Okay. When I say without being noticed, I mean that it was actively being used in the wild, but researchers and other security professionals hadn't figured it out yet. Okay. So it took advantages of changes that were made to the Windows Task Scheduler in Windows Vista. So before that, Windows XP was not secure, but basically they added on extra security features, and the way that they did it had this flaw. Okay, XP itself is far from secure, but it didn't have this flaw. So in Windows 7 and Vista and the other ones, 2008, scheduled task configuration files get stored as XML files. I think this is mistaken. This should be C Windows tasks, if I'm correct. Okay. Let me just double check that. I'm pretty sure. I could be wrong. Yeah. So it should be C Windows tasks. Okay. So anytime if you create a scheduled task, it's going to show up in there. Now, anybody can create a scheduled task. So that means that you have to have the ability to write to that location. Okay. If you're an authenticated user, you have read write. So you can edit your own tasks, but you can actually edit other people's tasks as well. The other thing is you can, when you edit your own tasks, what's to stop you from changing your task and making it do something as another user, right? So what stops users from elevating the context of their jobs is the question. And the answer to that is basically making sure that once the XML file gets created, you can't modify it. So jobs are configured within the XML file to run as the user who created them if you're not an admin, okay? And so if you're an admin, you can make any changes you want. But if you're not an admin, only the user who creates the task is supposed to be able to run it, okay? So when the task is processed, the task scheduler checks the checksum of the task. So it does a CRC32 checksum to ensure that the XML file hasn't been modified since it was created. Okay, so once you actually create a config, it gets locked in. There's a CRC32 checksum. If you modify it after that outside of the normal um, um, task scheduler, it's going to notice, right? That's the idea. So it doesn't want it to be modified afterwards. And now here, this is where that difference between a hash and a checksum becomes important. So we've talked about hashes before. A hash is a one-way function which gives you a unique ID for a file, and it tells you whether there was any kind of modification of the file, right? So whoever designed this as a programmer, when they implemented this, they didn't use a hash, they used a CRC32 checksum. Those also catch modification, but they don't do as robust a job. Okay. So the CRC32 can usually detect, say, network corruption of a download. Okay. Where it'll be like, yeah, this download doesn't match the CRC checksum that we have calculated for the file. Therefore, there's something wrong. This is a corrupted download. However, it's not a very smart algorithm. That is to say, it's pretty easy to intentionally create um, a file that matches the same CRC32 value. This is much harder with hashes. So the developer that actually did this checksum check for the task scheduler, they were checking for accidental corruption when they should have been checking for intentional modification. Okay. And so they should have used a hash instead of this CRC32 checksum. Now, whoever created this hack in the first place noticed this and figured it out. Okay. So CRC can catch accidental modification, but intentional changes can be introduced. That is to say, you can create a collision where two files are different, but they produce the same CRC. Okay. So what someone figured out was that with an XML config file, if you insert a comment which has no effect on the config file, but it modifies the file in such a way that the CRC32 checksum doesn't change, then you could go and add other changes to that XML file, add a comment that brings it back to the correct CRC, and then execute it, right? And so that means that you can actually hack and play around with scheduled tasks that are already there, and the CRC will still look good, you know? So what do we use here? We create a task as a standard user that's going to create a new user and add it to the administrators group. That's the idea. Now, as a standard user, this should fail, right? Um, and we're not really able to change the identity of the user that this is going to run as. But if we create that task and instead of running it, we then go and we modify the XML config so that instead of running as us, it runs as system. Okay, so not administrator, but the system account. Then we don't have to provide a password. And the normal thing that blocks us from making that change is the CRC check, right? So what we do is we make that change, then we calculate a comment in XML, which has no effect on the XML file, but will allow us to get us back to that CRC result, which the original task had. We append that comment to the end of the to the end of the file, let it run, and then it'll run as system. It'll create that admin account for us. Okay, so pretty straightforward. Let me just go over to that now, and we're going to poke around a little bit. Okay, so if you log in as tech, so tech has no special rights. Okay, and I'm just going to right click on computer. I'm going to go to computer management. I just want to show that we're not able to do things, right? So we go to local users and groups. And I just want to create, I'm pretty sure I'm not any special user here. So let's just say Matt. Okay, and I shouldn't be able to create this. Password never expires. And I get my access denied. It doesn't like this, okay? Because I don't really have the permissions that are needed to create this administrative account. So what we're going to do is we're going to open up this task exploit folder here, and I've got a couple of files. Now, this I can't remember where I got this from. It was somewhere online. It's kind of funny, though. It's like a script kiddie kind of put it together, or they used it, but they didn't quite understand it fully. Okay. So what we've got here is the XML file, which creates the account, right? It's the modified. We're going to modify it, and then we're going to elevate privileges with this Visual Basic script. Okay, so I'm going to edit this Visual Basic script here. Now, this XML file, it's just a template for what we want to do. The idea is we're going to put that into the task folder, okay? But we're going to do it through this script. So the author of this is somebody who decided to call themselves Web Devil. That's not me. But they made this a while ago, right? And they actually made a mistake when they set up this script. So they wrote some pretty good code, or they copied some pretty good code. I'm not really sure what. However, and I don't know if this is intentional or not, but they made an error in the process so that this doesn't actually work. So maybe I'll give you an example of it not working just to show you. Okay. So I'm going to open up a command prompt. And I don't have admin rights, so if I run as administrator, it's not really going to give me any special rights. Okay. Now, what we're going to do is we're just going to cd to this folder. So I'm going to copy that, cd, paste. There we go. And I'll just do a dir, make sure I'm in the right place. Now, when I actually want to run this, maybe I can make this a little bit bigger for you. Hold on a second. That looks a little better. Can I extend this? Yes, I can. Okay. Apparently it doesn't. Hold on a second. Nope, doesn't like to go any wider. Okay, let's try this. No, that's not much better, but we'll work with it. So I'm going to do, I think I have to do the script. I may have to provide the path. I can't quite remember. /v for L, and we're just going to run it. Okay, so it did everything right. Let me just refresh this. But it wasn't able to create an account. Okay. Now so when I first got this, I was like, oh, this sucks. This doesn't really work, you know? But if we go down and we look around a little bit, what we need to do is understand how the whole thing works. Okay. So there's this giant table here. This is the CRC table, which WebDevil is using to uh, basically to create a matching CRC value. Okay. There's a couple of functions to convert decimals to hexadecimal and back again. Okay. I'm not really going to worry about those. We're just going to go down to the main part of the script, okay, which is right here. So what we're interested in is what he's doing on the operating system. Okay, so we can see right here we've got task schedule is 0 day, privilege escalation, and he's got that right here. He's just printing that out. Should work on blah, 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 blah. This is done by WebDevil. You can even, it leaves his email address, which is kind of funny. And then he creates a batch file called batch file, where he's going to run this bat file, okay, which creates the account essentially. Okay. So the command that's in that batch file that he's creating dynamically calls on scheduled tasks, uh, and links it to this XML file, says it runs it monthly, but it's actually going to run it right away, right now. Okay. Now, the content of the batch file here are these 3 lines. So net user add test123, test123. Okay. So that is creating, it's trying to create a user called test123 with a password of test123. Then it's trying to do net local group administrators add. This should have worked actually. Hold on a second. Refresh. There we go. Okay, so it did create a test123, right? But if we go into that user, we can see that he was never added to administrators. Okay, so it did manage to create it. The GUI just didn't show it right away unless I refreshed, but it didn't add it to the administrators group. Okay, and then it deletes the scheduled task after it's done. Now, why did that fail? Why did it added the account, so it elevated privilege, but it didn't actually add that account to the administrators group. The reason is they made a mistake here. They either made a mistake or they intentionally kind of broke their own script so that you're adding an account called WD to the administrators group. But we didn't create a WD We created the test123, right? WD was the name of the XML file. So I don't know if it was just like, just a brain fart, or if they were like, look, we don't want somebody's little brother to be able to elevate privileges. So we're going to make this, but we're going to kind of sabotage it a little bit. Okay. But what we got to do then is we have to change this to make sure that it says test 123. Okay. Now, I could do other things. Instead of creating a new user, I could reset the password of the administrator account, right? There's different things that you could do, but we'll just keep it like this and fix the bug that they had. Now, the first thing I'm going to do here, I'll just switch user. I'm going to log in as admin. I'm going to get rid of this guy because we want to redo it. Okay? We're just going to take him and delete that bad boy just to give us a fresh start. So we go back, log out. Go back into tech, and I'm just going to refresh this. He's gone now. Okay. So we fixed up that administrator thing. We're going to rerun this script and see if it does anything better for us. Okay, so you see here, it finds the original CRC, right? It finds out the magic set of characters that it needs so that after it changes the XML file, it can actually bring it back to the original CRC value. And then it shows you that the original CRC value is restored, right? Even though we made changes. Okay. And then if we go here and we do a little refresh, we've got our test 123. And now if we check out its membership, it's actually added to administrators. So we actually have a functioning account that now has administrative access. Okay. So if I just go and I switch user and I log in as test123, what's the password? Test123, right? And that'll let us get in. Okay, so I'm just going to kind of let that log in. I'll do the, oh, no, it's pretty much ready to go. Let's just do it. So all I'm going to do, I'm not going to delete him, okay? I'm just going to take him out of administrators. So he's still around, and I'm going to log out. I'm going to go back to tech. Now, tech, even though he was able to elevate privileges, tech doesn't have any special rights. So when I click in here, I see that he's been taken out of the group. But if I actually try and delete him, I don't have access still. I'm not running with any special privileges. Okay. Okay, so I'll minimize this for a sec. We're gonna finish this bit up. So in the wild, this exploit was one of the two exploits used by Stuxnet to elevate privileges. Now, if you don't know or you don't remember Stuxnet, that was during the Obama administration. There was a hack that occurred in Iran that took their nuclear program offline for a number of years. Okay, they're kind of making their way back now, but for basically what happened was somebody infected their computers where they were doing their nuclear enrichment, and it took control of the machines and spoiled all the batches essentially, so that they were kind of set back multiple years by this process. And the way that they managed to take over the machines was usually through media like USB. There would be an infected USB. Someone would plug it into a computer. That computer would be infected. Um, and the malware that was written was using this technique to elevate privileges. That was one of the two techniques. Okay. The belief is it's pretty certain that this was the U.S. that was doing this, likely with the assistance of Israel at the time. Okay, although the U.S. is pretty clearly implicated in it. So this was used legit, like well, not legitimately, but it was used in the real world um, for pretty serious stuff. And they kind of, they knew about it and they chose not to share it so that they could leverage access into different people's systems, right? So this was actually used for a number of years before it was discovered and then patched for. Okay, so that was the first one. That was kind of you know heavy duty use. It was fixed by releasing a security patch, which what they do is they didn't replace the CRC checksum. They actually kept it in place. They slapped on top a new check. Okay. And that's actually, you're going to find often on the internet and in IT, uh, often we don't replace things completely because it's too involved. So we slap band-aids on top, to make sure that, because otherwise, like the whole internet infrastructure has security holes. The way that we fix it is by adding on top of them, not by taking stuff out because it breaks things usually. So what they did was, as well as doing a CRC32 check, they also do a SHA-256 hash. Now, the idea here is not only would you have to come up with a matching CRC32, but you also have to come up with a matching SHA-256, and the combo of those is even less likely. Okay, so it's a good fix. Really, it's better than just replacing CRC with SHA-256. Now, both of them have to be compromised in order for this to work. That's a lot of work. Okay, so that's a good fix. Nonetheless, there was still a task scheduler hack in Windows 10. It was just it had a different focus. Okay? It didn't focus on the hash itself. Okay, case study two. This is the Intel sysret bug. This could have been a really bad one, but we lucked out. As far as we know, nobody figured it out until the security researchers discovered it. Okay, this is a flaw in Intel's implementation of AMD's sysret operation. So sysret means system return, okay? And that's an opcode which is in AMD architecture. So it's in the hard, it's built into the hardware, okay? Now, AMD implemented this sysret option. The idea is when you're switching between a host and a virtual machine, you're changing privilege levels, okay? And so the sys return essentially brings you back from like some virtual machine to giving control back to the operating system. And so you're going from one level of privilege to another. They call it rings, okay? Your different rings of access. So you have your user ring. In the old world, you used to have your user ring and you had your operating system ring. But in between that, we've got now virtual machines. So sysret is essentially moving you between these states. Okay. Now, AMD implemented their sysret and they did it cleanly. So if you're running this code on an AMD system, then there's no bug to take advantage of. The problem is that Intel on their hardware, they implemented a sysret operation so that code that was compiled on AMD is going to run on Intel. Okay. So they're saying we want to be compatible. So we're going to implement our own version of sysret on our hardware so that code can be transported easily. The problem is Intel's implementation of sysret has a flaw in it. Okay. The effect is that you can compile code on AMD, move it over to an Intel system, and you can then hack the Intel system. Okay. If you compile that code on an Intel system and then you run it on an Intel system, nothing's going to happen. But if you compile it in the right way on an AMD system and then you run that on an Intel system, you can actually hack the entire operating system. Because what's going to happen is when the sysreturn call occurs, there's a buffer flow, a buffer overflow that's capable of happening on Intel systems. And so if you write code that triggers a buffer overflow, when you're switching from one state to another, from one ring of access to another, You can trigger that buffer overflow and strand the process in an elevated privilege context. Okay. So effectively, you can make any process you choose act like it's part of the operating system. So this affected all Intel 64-bit architectures running AMD. It was not just a Windows issue. Okay. This affected FreeBSD. This affected Linux. This affected Apple when they were running 64-bit Intel. Okay. So everybody was affected. Um, Now, then it was the question of what was the response, right? So Sysret, I mentioned this already. The AMD implementation is secure. So if you're running on AMD hardware, no problem. Um, but if you're running on Intel hardware, you can gain kernel mode access. Okay. So it attaches to a process like Explorer. That's one we're going to use as an example. And it gives the logged in user kernel rights through this buffer overflow. Okay. So you got to run it with a PID parameter. We'll look at that later. And then it triggers that buffer overflow and traps the process in kernel space, which is highly elevated. Okay. So the open source OSs were very fast to release a patch. Linux actually kind of accidentally fixed the problem without realizing how serious it was. So they were not vulnerable for years. They noticed it way ahead of everyone else. They just didn't realize exactly what it was. Okay. FreeBSD issued a patch very quickly. I think Apple was pretty decent about it too. Microsoft took 3 months to release a patch. And Intel was like, not my problem. Yeah. They said, yeah, this is a, like there's an issue here, but it's really up to the OS developers to handle it properly. They shouldn't be allowing buffer overflow, which is totally true. Okay. They said we documented how our systhread operation works. We're obviously not changing our hardware, so it's a legitimate thing to say. And the OS developers have the ability to avoid this problem um, once they knew about it, right? So the weakness had existed for 6 years before anybody noticed it, except for Linux. Linux kind of noticed it, okay? But there were no known exploits associated with the bug. So we've never found anybody who used it in the wild. But it's a very nice little exploit. So let's go visit that one now. Okay, so we need to go into a new folder here. We're going to go to the sysret folder. So I'm going to change directory to that. And we got a couple of executables that we can use. Okay, so we've got a DLL with the sysret exe. I'll just try running sysret and we'll just do a question mark, see what it says here. So what we need to do is we need to associate this with a process ID. Okay. To do that, we want to go to our friend, the task manager. And we want to look at the processes that are there. I want to see all users if I can. That's not many. Wow. Windows has become very bloated. No, it's not showing everything. Hold on a second. I want more than this, or do I? No, I really just want Explorer, right? So what I need. Oh, here we go. No, not set priority. You know what? I'm not going to use this. I'm going to use task list. That'll give me what I want. I'm just going to run the task list command. It'll show me similar stuff, but it'll give me everything I need. So I'm looking for the PID of explorer.exe. Okay. So when I log in, my Explorer window is what gives me all the graphical windows that I can play with, right? Everything starts, at least from my user space, everything starts from Explorer. So we've got this Explorer exe of 464. So when I'm running this command, the sysret command, I want to pass the PID 464. Okay. We're going to go sysret dash PID 464. And you're going to see it's going to trigger a buffer overflow. And what's going to happen is that this window is going to become unusable. Okay. So I'm just going to minimize it. But now you remember before we tried to delete this account and we weren't able to. Now we're going to say, yeah, I'm sure I want to delete it. Oh, it's still giving me access denied. Hold on a second. Let's just see. That looks like it's okay. Let's just open this up here. Maybe I chose the wrong one. Come on, baby. There we go. So I did have to start a new computer management, but it actually lets me delete everything. Okay, even though I had no admin rights. So if I restart or I log out, then my Explorer process is going to disappear and I'll lose that elevated privilege. But right now, I'm running with the rights of the operating system. So I could do all sorts of things on this system as if I was an administrator, even though I'm not logged in as one. Okay? So feel free to play around with this. You can grab that VM down from SharePoint, extract it, and there's an exercise that you can work with on that. Where you can just duplicate what I was doing. You can mess around with it a little bit, see what you can change to make different things happen, you know? Any questions about that? I still have more lecture to do, but this was kind of the big one I wanted to get through today. Okay, no questiones. I'll cover this fast. This is 16 slides, but we don't need everything. I just want to intro SQL injection for you. Okay. I'm not really going to focus on cross-site scripting, so this is a lecture that covers both. I'm going to go lighter on the cross-site scripting, but it's the same principle, essentially. Okay. We're not really going to do cross-site scripting in this class, although it is an interesting little topic. So, but the focus will be SQL injection here. Okay, so the reason SQL injection works is because of the way that we design the architecture of websites. Okay, so you have a web server which has scripting technology built into it, and it's talking to a backend database which is using SQL, okay, or some other programming, some other database. But typically they're all SQL based, or they have similar issues. Okay. Um, so all of this is the standard, the trinity of this is HTTP plus scripting, some kind of scripting language, plus a database, usually with SQL. Most websites accept user input, usually to do things like log in, but there are other things, you might upload an image, you might type some text on a message board, things like that, right? And what typically happens is that code gets sent to the web server. The scripting language processes it, and then potentially some of that data gets stored in a database. Okay? So what that means is that there's an opportunity to actually send messages to the database. And if you're lucky, you can send SQL commands to the database. If the people who designed the website didn't really understand the concept of SQL injection, then you may be able to make modifications to the website and the way that it behaves by modifying the backend database. Okay? So here's a sample, some sample code, a string that maybe would be used, a very conventional string, not a very good one, like an insecure version of some code that might exist in a script somewhere. Okay. So you have a string which is saying select everything from the user table where the field username is equal to, and then it's inserting a variable provided by the user. Okay. So Matt, right? When I'm doing a SQL query as a programmer, I want to do select, give me return all the entries for me where the username is Matt, and that Matt username is provided by the user. Okay. Full speed traps and clears. Yeah, exactly. It's very, very common, actually. It shouldn't be these days. People should know better. Programmers should know better, but they don't necessarily. So let's say instead of providing Matt as my variable, I actually provide C, closing of a quote, or 1 equals 1 dash dash. Okay. This is kind of the simplest SQL code that you could do. But the idea here is that your query then becomes, instead of, give me all the users where their username is Matt, it's going to do, give me all the users where the username is C, or where 1 equals 1. Okay. And now there may be no users named C, but it's always true that 1 equals 1. And so all of the users in the table are going to be returned. Okay. So this is a good way to dump information from a SQL table if it's improperly, like if the programmer is not checking for any kind of misuse or insertion of SQL code. Okay, so I just kind of explained that. The 1 equals 1 is what allows all rows to be returned. But really, the secret sauce in here is that we're closing out the query that was originally intended, and then we're appending extra conditions on it, which actually give us more information, right? So this satisfies the original query, C, and then closing of the quotes. But then we say also, or 1 equals 1, which is a very permissive question. And then dash dash says, anything that comes after this, I want you to turn it into a comment. I don't want you to process it as code. And the reason that that gets done is just in case the SQL query is not quite what you expected, it had more to it, you can just cut it off at the legs, cut it off at the knees, and then control exactly what you're requesting as a hacker. Okay. So since these two queries are ORed together, the C and the 1 equals 1, all rows are returned in the username table because 1 equals 1 always returns true. So that's not the intention on the part of the website designer, but that's why we're hacking, right? By allowing input to contain code, the developer has left open a hole for us to take advantage of. So this is essentially what SQL injection is. You can get much more specific in the queries that you make, which can be handy. Sometimes you don't want to dump the whole table. Sometimes you want to combine information. You can do some pretty advanced SQL injection if you get good at it. I would not say that I'm not good at it per se. I can read it. I can understand how it works. This is a bit of an art, really, in terms of how to, it's SQL database whispering, right? So injection attacks are dependent on the fact that the developer didn't check their inputs properly. So they're taking in a username field, but they're not setting any conditions on what that value could be, right? Very, very common to find this in database-oriented web interfaces, but any application that uses input to create a SQL query has this risk. So I'll give you an example. When I was an admin in my early days, I was working for a nonprofit, and they hired their own coders to do various programming tasks. Okay, and as the administrator of one of their domains, I got an email from somebody who's like, "Hey, I was able to hack into your database. If you pay me some money, I'll show you how to fix it." You know, which I took as a veiled threat. But I went over to the programmer who developed that website and I said, okay, well, he's saying he could do this. And so we looked at the code together. And that's when I first learned how SQL injection works. Okay. So we figured out that he hadn't properly checked the inputs on the username password. And then he was like, he was a French guy. So he was like, oh, lo, 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 lo. As in, like, uh-oh. Because a whole bunch of their websites had this problem. He hadn't really thought about it. He had to go and fix all of them. Okay. But he'd also developed some code that was resident on lab machines, um, where every time a user logged in, it was tracking metrics about how much time people were spending on the system, what kind of applications were being opened. Those are all metrics for government funding because it was a nonprofit, right? And what he realized was that this app he'd integrated into the Windows login was also subject to this SQL attack. And so I tried it out, and it would always give me the same user, but I could log in just using SQL injection and always become this person, you know? So it's not just a website thing; it's a SQL thing, and it is something that you have to watch out for. But in the end, he recoded everything, and it was all fixed up. Okay. Now, a more malicious kind of query you could do is say C for the name, like C, close the name, and then just say drop table username dash dash, and that's actually if the account that is doing the SQL querying, if that has the rights to change the table, then it will actually drop all the data in that particular table, make it disappear. Okay. So you do need to know the name of the table. That might take a little bit of poking around. You have to type a few other commands first. We're going to play around with this in next class. Next class is exercises. Okay. But you can query for information, then take that information and apply it to new queries and dig out a whole bunch of stuff out of this. So if the identity used to access the database has more than read privileges, that's one thing you can do to help secure things is if the account doesn't need write access, don't give it write access. You know? If all you're doing is checking if a username exists, that doesn't need write. And so that's an administrator side thing, not a developer side thing, but it can help you. Okay. Now, how do we try and fix this? So there are different things people have used. One trick that has been used in the past and turned out not to be a great solution is to convert any single quotes in the user input with double quotes. So in other words, if I'm using single quotes in my SQL queries, but I get a single quote in my user input, I'll automatically change that to a double quote. That will break the SQL syntax and the problem goes away, in theory, right? Problem with that, so we did do that in the past as our first response, right? The problem is you can actually represent characters in different ways. And so the single quote, instead of showing up like this, it could be literally typed in as OX27, and that'll still be treated as a single quote, but your code won't convert it to a double quote. Okay. Why is that? Because the scripting language sees OX27, SQL sees a single quote. Okay. So uh, it's not all data is not always represented the way that you expect it to be. So simply converting things over is not the right way to actually stop SQL injection. Okay. So looking for bad data is a bad solution, really. We don't know the form it might take. That can be very hard to predict, and people can do interesting somersaults with encoding in order to get data through. So instead, what we recommend here is you check our input for something that we have defined as good data. Now, the best way to do that is with something called regular expression. Now, a regular expression, I'm gonna skip this part for cross-site scripting. Feel free to read it if you're interested, but I'll just kind of move on from that one. Okay, so as with SQL injection, the main problem is insufficiently filtered user input. So what we want to do is look for good input. And the way that regular expressions work is we just define, I'm only going to allow uppercase, lowercase. So you've seen it with passwords, right? You need to have uppercase, lowercase, and numbers. Okay. That's something that they can say for complexity purposes. But when we're doing it here for protection, we're saying we're only allowing those. Okay. So if somebody passes in a username that contains anything other than uppercase, lowercase number, and maybe a list of certain special characters, anything else, we're going to say, no, this is not a good input. We're not going to work with it. Okay. And so regular expressions are just a pattern matching tool where we can define, you know, uppercase, lowercase number. And if it doesn't match that pattern, it'll generate a negative. If it does match that pattern, it'll generate a positive. And then we handle those two cases separately. So basically, we're blocking any kind of exotic strings from coming into our inputs. Okay. Now, beyond that, different languages, so C Sharp, PHP, they have modules that you can include that can help protect against these attacks, even if your programmer is a bit of a dumbass. So if he has no idea, and I'm not saying they're really dumbasses, but um, if they're not trained in this, which they should be these days, but if they're not trained in this, there's still some protections built into the scripting language these days. They're not 100%. Okay, nothing is 100% here, but they do raise the bar against the attacker. Okay, the real key is programmer education. It might be like in my case, like I had to explore the coder's work myself and figure out SQL injection in order to teach it to him. Okay, because he didn't know about it at the time. And so luckily I had a little bit of programming background myself. So I was able to kind of spot, I looked at the attacker's uh, um, kind of queries in the log files, and then I tried a couple of them out, and I started to understand what was going on, you know? So sometimes the sysadmin has to come in and kind of give a little bit of insight. Sometimes it's not really your bag either, you know? There's this middle zone. It's like in volleyball. When the ball lands between two people and each person thinks the other one's supposed to get it. That happens in security with programmers and sysadmins a little bit. So it's always nice if you can kind of spill over into the programmer space. If you have a little bit of their knowledge, that can help fill that gap. Okay. Same thing with a programmer. If they have a little bit of sysadmin knowledge, that can help, and then you can understand each other a little better, and you can avoid these issues. Okay, that's my SQL spiel. Woot woot. Any questions? I'm done talking otherwise.